Hello, everyone, and welcome to the broadcast. Just to verify something here that I forgot to check. There we go. Today we're going to see if we can't get to collision handling in our game dev here. Now, that does have some changes that we need to make before we get there. We need to have a separate entity type. We need to set up some collision surfaces to work with, and how to get the entities in them, all that goodness. But we're going to try. Before we do get into that, though, let's check in with the kitties. We do have Sky on the side of the desk there, kind of half snoozing, giving me a bit of a side eye there. And Mason and Sammy on the bed. I think that might be a sherbet paw in his tree. Let's check. No, wrong one. Window tree. Window tree. Where Ember is hanging out. Yep, that's a sherbet paw. All right, but if you recall, last time we did have, we did get about here. I did find out that the move to cursor is pretty process intensive. We'll have to figure out a way to clean that up. Find out if there's a less expensive movement option. You can see that it's costing anywhere up to like 7 frames a second to have the blobs trying to move towards the cursor. It varies, but it is there. Now, one fun thing we can see is that the blobs are facing to some extent facing the mouse cursor, but they face in the direction that they're moving. Left-right aligned. That's good. We also have all of this texture stuff happening within the shader now. I think there's still some tweaks we'll want to get to on that front. But for now, we've got some of it hard-coded. Go to our shader editor here. Animations and animation are currently across all of them. I'm not too worried about that. This is what lets us do the shader level texture mapping. Do we have a lot of extra space? Yes. But we do need to predefine this in a shader, allocate some memory for it. Currently, I'm not seeing us get to 100 textures, but we can always bump that up as we need to. Hey there, Erebus. We're hoping to get to collision handling today. Snake, it's moving along. Let's, Lurking is just fine, Erebus. Lurking is just fine. So we've got shader level animation going on. We've got a lot of clean handling. Mouse cursor dragging movement is more expensive than I'd like. We have a lot going for it right now. I think enough to move on and get the collision going before we need to add any additional visual handling. We've got them facing different directions. We've got them performing lots of movements at once. And if we remove the move to cursor logic, then we can hold it at close to 60 frames a second constantly. Sometimes a little more, sometimes a little less. But it's not as visually interesting if we don't have the A lot of rotate ins, but... Oh, that's right, because rotate in chooses its motion right there at the beginning. We don't have the tall view at the moment. Because I'm trying to start earlier in the day, I can only have 2 streams active at once, and the tall view ends up getting sacrificed to that requirement. We pull random direction here. We might get something a little more visually interesting. Twitch is fine. Twitch is still running. Now, in theory, they should start converging back in soon. Yeah, they get dragged to the cursor. Interesting. I think we might have been hitting a threshold for number of executions, really. But move to cursor is still relatively pricey. Yeah. We're still holding in there. What I've been doing offline up until today, since our last stream, was getting our mesh render over to the new pattern. So now there is just one instance that the mesh renderer creates. It creates one multi-mesh instance within itself and then monitors that content here. Like, we don't set a texture in it anymore. Instead, we're going in and adding additional parameters. We do need to get this stuff into the custom data so that each individual texture has that handled. But we're mostly there. Since everything has about this much as far as animations go, we should be okay. The exception will be the player sprite, since it has extra animations. And we need that. This guy is trying to bully Ember again. Let's see. Oop. That's not what we want to do. Because I think the easiest way to get collision initially is just going to be to get the player in there, so that we have a definitive location for collisions to be happening. And the player has 4 animations, 2 of which we don't use. So we could go into our texture wrapper and add the stuff here. Some changes we made to texture wrapper is we added a key here. This is the key for the texture itself. We use that because in the mesh render, we are getting the texture index based on the key name. And that comes around when we are rendering an individual thing here where we set custom data. Custom data in a shader is a color. It is a 4 float value. So we can get away with a bit of shenanigans on this by doing things like bit fields and similar in the color values. It is not ideal because they're floats. There can be some oddities in that, but since we're not operating on them to generate them, we shouldn't run into those little precision hitches. But we pass the key in, and we pass the identifier in. Identifier is another thing. We'll get to that in just a moment. The index is used in the shader right here. We get that out of custom data, which we get during the vertex. Get the X, and we get the Y value here. We use the ID to offset our animation so they don't all move in sync. If we remove entity ID, if it's 0, then they'll all move in sync. The texture index is used here. Since we passed in all of those textures, we get the index of that texture and use that instead. The reason that we are going to need to know the right number of animations is this in here, where we determine of the entire sprite texture, what is the proportion of the different values. So if there are 4 animations, the proportion of the Y coordinate is in 4 rows. So we have a if there are 4 rows and a single frame, it's then any individual position is 1/4 on the Y coordinate. Whereas on the X coordinate, it's always going to be 1/6 right now, because an animation frame is 6 long, or an animation is 6 long. I will be able to change that to make it so that however wide a sprite sheet is how long the animation is. Is it technically possible to have shorter animations and longer animations on a given sprite sheet? Yes. But that gets fiddly fast. We would need to accomplish it by having each texture having subsequent values in it. We'd be looking at multi-dimensional arrays at that point, saying this texture, animation 2, is this long, kind of thing. Again, is it possible? Yes, we're not doing that yet. But to the point, if there are 4 animations on a sprite sheet, then we need to do the math a little bit differently than if there are 2 or 3. We do the math the same way, but the values are a little different. So we need animation data to get in here. And I think the easiest way to do that is to put it in here as a uniform, since the number of animations is fixed per texture. Like, Sky, what's the matter? It's running around chirping at me. Okay. So, we are planning on getting to physics. I just need to shore up some of this so that we can get some additional animated entities in place and go from there. The player is a impetus to get all of this working. Oh, if you're curious, filter nearest is for these textures. If I don't put that in there, the textures are blurry. Okay. So when we are setting up the sprites, it used to be that we had to parse all of these out into individual things. Let's just get rid of that. We don't need our try-catch around this. It was good for error handling, or at least to find out what was going wrong with the process. We may still do that on some of the things, but we'll get there. Quad mesh size for the time being, everything is 16 by 16. I may change that. I may make it so individual textures can have different sizes, but in order to do the different sizes, we would need to have math to convert coordinates in a smaller frame onto a larger frame and vice versa kind of thing. So the quad mesh would always be scaled to the largest texture or frame size, but the individual pieces would need to be then adjusted accordingly. So if it's 16 by 16, and normally, if the largest one was 32 by 32, and I had a 16 by 16 frame, I would need to move the sprite pixels in proportion to that. So the coordinates that it would render to would be twice, would be double. And would be halved in there. We would have to get them into the middle instead of at the edges. Now, we could do it without changing that and scale it up, essentially. But we don't want to do that. We want whatever pixels I'm rendering to match what's in the sprite. We don't want to stretch pixels. Anyhow, so now we need to set up another array of integer values that is number of animations. The samplers, I'm calling them samplers because that's what they are in the shader. A 2D texture is a sampler 2D in the shader, so we're using the same concept. We could call them textures. Okay. So we get animations. So for each one of these, we get our texture indices that we're adding. We're getting our textures, which we're adding. We're going to get animations. We're going to get a texture wrapper here. I need to try to find a setting that is how fast the IntelliSense triggers. Use texture anywhere else. All right, we can save a storage variable. Oh man. Texture wrapper. Frame size. Y. Will this always be an int? Yes. because the texture and frames are integer values. But since these are vector 2s, they're float on the way through. That. Still not 100% legible, but you know. So now we have an animations value. And we're going to need to have that be a part of the custom data that comes in. Gotta step away real quick. Be right back. And we're back. Okay, so instead of this being a uniform shader parameter, in order to get it in here for usage by all of them, I'm sorry, instead of a single uniform integer, we're going to say this creates a conflict between the two of them, between these two values. So now we have animations. And we put in texture index here. Animation is still relevant. That is something that we need to load into our custom value now. Flat animation. We will need to refine this so that we have more room to put this stuff in. But we'll get to that later. Again, stuff like frame size becomes relevant to put into this kind of thing. But in order to get it in there, we're going to need to convert this over to, like, effectively into composite values, like the the first x part of the value is this variable, and then the next x part of the variable. So if you were to break it apart into, like, digits, that's where we'd be going with that. Okay, so we're loading textures here. Like that. So now we have those values loaded in. And then when we are rendering them, when we're setting the custom data, we have the entity ID, and now we are going to have the entity mesh animation. For some reason it decided to eat a paran there, but you know. We'll get to that. Make sure I didn't break it. Now you can see this almost like stuttering behavior here. That is an optical illusion caused by the animations lining up, where frame by frame it looks like they're just like twitching back and forth, but that's that whole line changing animation in sync in a particular way. Okay. So by making the change that we just have, I can now have different sprite data loaded in. We will want to set up variables for this. Animation, and then we have so okay. And this is, like I said, something that we need to figure out how to do. For the time being, though, we'll deal with it as is. So now we're going to need another entity, which will be set up in the catalog. So we already have entity player that we can set up. Reduce the number of these so that we have a bit of a cleaner flow of behavior. This will cause a huge number of collisions to default the way we've got it set up, because all the slimes would appear right on top of it. We're going to need to set up that random positioning again during spawning for the slimes to make this work. So here is the player. We are copying the current entity to do that. Which we don't want currently. So we'll set a texture key. We'll do all of this. And we will set up a new entity here. And it is going to do all of nothing. Because we don't care. It's just going to sit still. Key of the Nyanite, and then in the entity manager, we are going to create a new entity right away. But we don't want that right at the start. Okay. That's how we'll do it. In the game. In ready. We are going to do entity manager. Add entity. And this will be catalog. Not get entity. Catalog. Entity layer. Getting started here, Sky. We're getting started here. How you doing? Haven't seen you in a bit. Now we can see the little guy there in the center. We will have to figure out a way to get him sorted properly. But yeah, you can just see the little guy's ears cropping out from the slimes here. Okay, but we have a separate entity in place now. Here, we'll get these loaded faster. 25, 125, 625. Let's go. Blorp. Okay, we're doing it this way because this is going to give us the opportunity to just hammer on the collisions. All right. So for the pattern that we will be using, real quickly, we will get a commit going here so we don't lose the work we just did. All right, so the pattern that we're using, so we have an entity mesh here. This is representing entirely just the visuals of the entity. So we have our texture wrapper, the corresponding ID of the entity. We use this to offset animations. It will become important later. Position, which direction it's moving. This is relevant for things like the mouse, which is kind of like a top-down sprite that rotates in the direction that it's moving, whereas the blobs in the player sprite only face left or right based on which direction they're moving. They do not rotate. We subscribe to relevant events here. So whenever a entity updates its position, the corresponding mesh gets notified. When that entity tries to go away, it gets notified, it desubscribes to those events, and then it broadcasts its own get rid of me message. The mesh renderer, for each of those, adds a mesh. We need to set up our event here. So entity mesh. Move entity mesh. This equals on remove entity mesh. In a similar vein, once we're done with the entity mesh, we desubscribe to it. And then in the exit tree of this one, we need to clear this mess out. Things that I forgot to do. Override. Exit tree. Desubscribe to this event from the entity manager. So we stop caring about this. And then we're going to flush out each of the entity meshes in the collection here. Actually, we don't need to. We just need to desubscribe to this when we leave the tree. Oh, sorry there, Andre, over on the Twitch side. I did not see the message come in. Can I format this differently? Make it easier for me to spot your messages. No. No, well, hopefully I'll spot them easier going forward. Actually, we might be able to get that easier. Where are you hiding, Twitch chat? Just so. All right, that may work better. Well, that's good. That's good. I don't feel as bad. And I thank you for the compliment. Let's see here. So when the game is ending currently, we call clear entities, but that's only when this exits the tree. I think that should still work. All right, well, thanks for swinging through, Erebus. Should still work. Should still work. Then stuff and things. Stuff and things. All right. Okay. Collisions. Gates targeting. Rendering. All right. So we need an entity that is akin to what we were using previously for rendering. And the reason that we need that separate entity is that we're going to need to make it for each of the collision layers that will exist. New item. And the collision manager is going to extend a node 2D. Which is using Godot. Commercial, public. Then add a collision manager just in case. Okay, then we need area 2Ds. It's not a collision object or a shape, it is a public area 2D. This would be a dictionary. Which I think is an int. Yes, that'll be fine. We are referencing collision areas based on a index for the areas. The collision areas themselves will have that collision set up in here. So we'll have some constants for what the settings on those collision areas will be, and we will go from there. Collision areas are set up for their collisions based on a bit field of layers. So, like 1, 2, 4, 8, that kind of thing. Above that. Collision areas. That. Area 2D. So we're going to have things like we're going to need to get some of the events on this for things like We might be able to do overlapping area and do the calculation there in one big pass. Hey there, Camphor. Welcome. We are monitoring this area and the collision area. Not. So collision layer and mask are what we want here. Collision layer is what its spot is. And then collision mask is what it's looking for. So in things like the case of the player, well, we'll set up those in a minute. But we set these up for each one, and then we're going to have collision areas dot add collision area here. And we will set up a couple of constants. What's the syntax for this? Is it... It's not a collision type. It is a... Collision type is just as viable as anything else. We can always rename that later. One, then bullet, two, enemy. So what we'll be able to do is say, okay, actually, kind of want a failure case in this, so we're going to have it be, it will not have a 0 case. We can add other types later. Into our collision manager here. So we can set these up to be different ones here. So we're going to have, this is a collision layer dot player. I don't like that. The target today, Camphor, is collision. We've been getting rendering rolling, and now we want to make it so that the objects bump into each other. Or at least some objects bump into each other. Currently, the player's collision layer is just... We're going to index this based on the entity's entity type. Can I do something? We'll do that for now. So we're doing it by an entity type as which collision area it is. We're going to need that when we're adding the shapes to those corresponding areas and messing with those shapes. This one's collision layer is equal to collision layer player. And currently, the player does not seek to collide with something else. Other things will seek to collide with the player. This is relevant. This determines the direction of the collisions. So a bullet can run into an enemy, but the enemy doesn't run into the bullet. That way, the bullet inflicts harm on the enemy. Or the bullet determines how it will interact with the enemy, but the enemy does not determine how it would interact with a bullet. In that way, this one's going to be bullet. And instead, the bullet is going to look for enemy. I'm sorry, the bullet is on the bullet layer. And in its collision mask, it will look for enemy. And then lastly, this one is the enemy layer, and it is looking for the player. And we put that on the enemy type. doing that because we're going to reuse this guy over and over. So as part of this, we are going to need we're going to have some interactions with the entities to just say, when this happens, remove the corresponding entity for the purposes of collision testing. Part of the reason that we've saved collision until now is that it is the most complicated type. The most complicated setup. So each of these areas is going to have a series of shapes in them. Oh dear. No, this will still work. This will still work. Okay. So each one of these each one of these is going to need to have a queue of indexes. An integer, and it will be of a queue of integers called shape indexes. The reason that we need this is that in the physics server, when you are interacting with shapes in an area, they have a fixed index. So if I add two shapes, their indexes are going to be 0 and 1. If I subsequently remove index 0 shape, if I remove that shape, index 1 becomes index 0, and I lose the ability to keep clean track of it without updating indexes on a whole bunch of stuff. Don't want to do that. So we're going to make shape indexes. And hey there, Ezra Ben. We're going with that for now. Correct me if you'd like. We are working on collision handling today. We just finished up with some rendering logic. Let's just show some of that. So we've added what amounts to a player sprite to the middle there. Can't say that it rings a bell, but I lose track of names very quickly unless I am repeatedly reminded of their existence. Please forgive me that. Eventually, if we hold our cursor in the center, the slimes will slowly reach a point where they keep trying to orbit around that point. The outer orbits take a while to get there. You can see they swing through, partly because they emitted in pluses, in star patterns, so their angles of rotation are larger or tighter correspondingly. So now we've got them all drawing, and so now we want to make it so that they can run into stuff. So these shape indexes are going to be a list of just integers from 0 to probably we're going to go with the same pattern of 0 to twice the max integers, or the max number of entities that we are now using in the entity manager. Where whenever we create a new entity, we take the first thing from the list of IDs and put it there. Whenever we remove an entity, we take that entity's ID and put it back at the end of the list. So we will do in Collision Manager, we are going to do... Oh, we set that up the same way. Where is our config here? Yeah, I don't know if you were around for when we started down this road, but we switched from GD script to C#, and we have we can now sustain 6 times the entities. More than 6 times, but about 6 times. Okay, we're going to pass in an enumerable range. Indexes is equal to that, and then each one is going to have this is a queue of int queue of integers, which is indexes queue, and it will take that entity manager dot max entities. Then in entity manager, that needs to be a public constant. There we go. Just took it a moment. Then shape indexes, add indexes. Can I teach the basics of C#? Well, it's like C++, but way, way, way more forgiving. Basics, class-based, one interface, one inherited class, namespace back, namespace types, strongly typed. library. So again, kind of like C, you have loaded libraries that give you the types. Namespaces subdivide those types. You set up functions, you set up initializers, you roll with it. So if you're familiar with other object-oriented compiled languages, then it doesn't take long to get rolling with C#. Even if you're not familiar, I'd say it's pretty approachable. HTML and CSS, yeah, it's definitely very different than those. You can get closer with things like JavaScript. Like, that's closer, but JavaScript is a scripting language. So, some big differences there. But things like class structures and inheritance can be kind of similar to CSS handling, conceptually. You know, this thing is also this thing kind of stuff. So this collision manager is a node 2D. So, like in the case of CSS, if I had something that targets node 2Ds, it would target this. But if I had something that targeted a collision manager, it would not target just a node 2D. Yeah, if you want to start down the road of coding, then JavaScript, given you're doing some HTML stuff, would be the way to start. Oh, I will have to say, a bit clever there, Andre. A bit clever there. Now, I could collapse this into a subfunction, and I think I'm gonna. Avowed void. And it will take... It depends on to what level of fluency and what you're trying to create there, Ezra Ben. If you're saying just to get started, a couple hours, tops. Like, it's really easy to get started. Otherwise, again, it depends on what you're trying to accomplish. Fully integrated web server application with asynchronous operations, all of that kind of stuff, is going to take you longer than I push button, change color. Gotta be a way to type these. Boo. Okay, then we're gonna need type goes there. Layer goes there. Collision mask. Well, you had no problem with it earlier. Why do you suddenly need a uint? Fine, fine, fine. You can be an int. Okay. We are indeed, Parakeet. We are indeed. So now I can simplify this and say add collision area. And we are going to say so. That will handle all of that for me. Bullet looks for enemy. Sorry, bullet is on bullet. And it looks for enemy. Then enemy is on enemy and it looks for player. We don't use collision area because we set that up in here. Okay. Now we're going to go into the Godot side. And we have collisions now. So we're going to is a 2D scene. We create that. And we are going to attach a script, which is the Collision Manager CS. And then back over in Godot land, we're going to go into a game. We have a mesh render. We also are going to have... There's a bunch of lingering references to things that don't exist anymore. Not in any hurry to fix that just yet. Instantiate one of them. Save that. Compile that. Complaints about some warnings that we don't care about. Run the project, hop back over to the Godot side. Look at our remote. We have core, we have game. We have mesh render now only has one multi-mesh. Collision Manager only has 2 areas. Why only 2? There should be 3. One, two, 3. Oh, because the third time it airs out. Right here. That is because we pass in the same index a third time. So then we're going to run that again. Go back into Godot here. We look, and now we have 3 area 2Ds. Going to step away for a little bit, and then I will be right back. And we're back. The area 2Ds are going to be the entirety of the collision there, Parakeet. So the player will be the only thing in existence in the first area. Then only bullets in the second, only enemies in the third. Collisions can only happen between the entire areas, and when that area collides, we are going to look at all of the shape overlaps and create corresponding collision events for each of them. So for our testing purposes, we're going to call all of these blobs enemy types. And they're going to collide with the player object, and I'm just going to make them go away when that happens. So then in our catalog, when we are creating an entity, we have the blob here. Correct, Parakeet. So whenever an entity is created, the collision manager will hear about it, and it will tell that entity, essentially, well, it will use that entity to create a corresponding shape, and it will add that shape to the corresponding area with a fixed index. It's copied, it will share the same type. Okay, that's going to be a problem. Ah. Okay, that's right, because toCopy is just an enumerable, not the actual entity. We have to cast it to entity right there. Now, one of the things, we do not copy ID. ID gets set. Look in Entity Manager when we finally add it. So we get ready to add it. Then when we actually add it, we get an ID for it before we actually add it and invoke that entity was added. This way, this ID is set before we get into any of the handling logic. This is important. Because we don't want duplicate IDs floating around. That will create problems in other places. Category is equal to entity.type. Category dot enemy. That. No, it is just an integer that we keep track of. That will be extremely relevant in the collision handling. me show you. So in Entity Manager, when we initialize, we create a range of identifiers that is twice the number of possible entities. So there will be 30,000 ints. We use the same thing over in mesh renderer territory. Where we set up the entity mesh's IDs. Well, I'm sorry, the entity mesh, when it is created from an entity, where are you hiding? It uses the same ID as the entity ID. It isn't so that we can fetch it, it's just so that this is consistent. We use it as an offset. Technically, the mesh render doesn't really care, but it's an offset for the animations. In collision management, though, when it's collision management, shapes are indexed, and it is a resizable array, and it is purely by the number of them. So when we're creating one of these, when we're creating a new shape, the index of it needs to be an index of a shape that already exists or one that is going to be added. So if there are already 10, either I am referencing 0 through 9, or I am adding 10. And that identifier stays consistent for the lifespan of that entity. If it is index 4, it is index 4 until it is removed. At that point, index 4 in the shape collection inside the area does not go away. That shape is disabled. Because if it goes away, indexes 5 and later go down by 1, and everything goes haywire. It's a huge problem to maintain that. So we're not gonna. We're just gonna keep those shapes around and we're gonna reuse them. We are gonna have public void on entity removed. Then in our setup here, we are going to have entity manager dot entity added. We could rename these to be like entity manager on entity added. That is not a bad idea. We'll think about that later. All right, we are going to create an entity shape. Which is a new thing, which we will now make. I've always enjoyed structured thinking like this. It's part of what kind of let me get into coding. Is I like to think in that sort of flow of classes and similar. What is it called when we get shape data? Physics server 2D dot. Add shape. Here we go. So we have circle shape create and rectangle shape create. For the time being, it's always going to be rectangle shape create. It's going to return an RID. So we are going to have okay. This is going to be flaky, but so we've created the shape. Comically, parakeet. Comically, and I would... That's a good point. But I have actually heard differently on some of them that rectangle is less intensive within the engine, but I don't know that that's actually true. This should be true because it is distance from a point. This is shape set data. So every type of shape has its own params here. So in a circle, we just pass in the RID and a float as the radius. So for our purposes, we're going to start there. Then it will be... Click off of that so we get the gigantic IntelliSense off of the screen. We're going to start with 8 because all of the sprites are 16 wide. We could go a little bigger, but 8 should cover all of them for now. This is going to have to be something that I set up. And we could include things like offsets. So this creates it initially. We are going to want to have like a way to enforce this. So when I'm initially creating it, we can set up the data, but this is the fiddly part. I'm sorry. Because sometimes we're going to get okay. So when we're initially creating a shape, we've got the entity to reference. We have an index that we're going to have this in. This is something that's asserted after the fact. This entity is entirely for the purposes of setting the shape data. Set shape data. Nope. This should be fine. These are not persistent things. We are going to set this so that we remember which index it is. But it doesn't even need this. We're going to keep track of them. Oh, no. It'll be useful to keep track of this. Yes. Okay. Catalog. Get texture. Entity. Texture key. Okay, so how this is going to work is when the collision area detects that a new entity has been created, it's going to take that entity. Oh, I'm sorry. First, it's going to see, do I have a shape I can use? If the area does not have enough shapes available, based on the index we have retrieved as the next available one. So if the next available index is 3, and there aren't enough shapes to account for 3, so this would be, there aren't already 4 shapes in the collection, then we're going to add one, we're going to create one, add it to the collection, and that's now shape 3. We're going to create it, we're going to pass it into this, and then we're going to add it to the collection, and we're going to give index 3 to this one. So this is going to have public on, or let's see, entity dot position updated and remove entity. It won't like this because we don't have the right signature, which is this for an updated. For the purposes of a shape, it only cares about position. On entity move. Sure, I get these patterns correctly here. Delegate is outside of the class here. Event shape or entity shape. So we have a remove entity shape event. To position. Position is equal equal to position. One moment. Right there. Okay. We know what the position is here, but we technically don't need it. We don't need it. Oh. Event. Entity shape. Okay. So the reason we don't need position is that there's nothing about the shape that needs to update the position. It doesn't care. All it cares about is that it remembers its index. Because when the position is updated, we are going to say entity shape position updated, if it exists, dot invoke with shape index, position. If anyone cares, I update the position of the shape corresponding to me. Okay, so when the entity is added, we're going to figure out the texture key, and we're going to use that to update the shape's data based on that entity's texture. Then we're going to subscribe to the corresponding events for that entity. When the entity is removed, we desubscribe, so we stop getting those messages, and we call out, I am being removed, or remove me. The collision manager is going to see that. Oof. Yes, the collision manager is going to see that, and it's going to find that shape's index, disable that shape, and it's going to remove that shape from its collection, and it's going to words and things. It's going to disable the corresponding shape. It's going to remove that shape. It's going to remove that entity shape from existence, essentially. It's going to remove that from the entity shape collection corresponding to that area, and it's going to take that index and put it back into the available ones. Huh. So we add that here, and we are going to say public override exit tree entity manager entity added minus equals. This is what AI is good for. I keep saying this. It anticipated that's what I was doing. Based on the shape of all the other code I've been doing, this is what it thought I was going to do. Thought is the wrong word. I am anthropomorphizing code. But this was a suggestion that the algorithm came up with based on the rest of my code. That is good. Trying to have it code for you is moving your work to a different place. Instead of trying to come up with the algorithm, I am now creating the work of reviewing that code, which, regardless of what software development management might tell you, is pretty much a one-to-one operation. And then you have the extra work of correcting what it did wrong. So instead of doing that, just write it yourself and use it to assist you. Exactly, Tass. If you let AI write code for you, you still need to know how to code that code in order to review and correct anything the AI did wrong. Okay, so when we do this, we're going to determine which collision area we're dealing with. And that collision area has a list of shapes. That's a good way to put it, James. It is having AI code for you is like having a really enthusiastic junior developer working with you. They really want to help, but there's a decent chance they don't have a full idea of what they're doing, and you're going to need to assist anyway. Okay. So I can create them, but how do I handle a collision with them? Okay. I'm not thrilled with this prospect here, because we need a thing that we collided with. We need an entity that we ran into. So we need to know which entity to talk to. We can do that by subscribing to this event. But we still need the other party. And I want to avoid having to have a daisy chain of references anywhere. So I would like it if the entity shape doesn't care about the entity it came from. But that might not be an option. Because when a collision occurs, I need to inform the relevant shape you just got ran into. I'm sorry, we tell the relevant shape whether it is a you are the source or you are the target of the collision kind of thing. But in general, it's a you collided with this. So you ran into this thing. So I need a you and a this thing. And those currently would need to be entities. So I could store off the entity of that shape and get that for the purposes of passing around. So we use this to inform Can we bind a variable on these? If I could bind a variable, then we could pass in fixed values and say, when I call, like, when a collision happens and you raise that event, it is always with this value. So, like, when I am being set up with this entity, I can have those variables set. But that still... No, that still wouldn't work. I think I need to store the entity. Man, I don't like that. But I think it makes sense here. Because the shape has to talk to the entity. Whereas with the rendering one, that the renderer never cares about what the entity is aside from getting events from it. But in this case, when the shape gets a collision, we need twofold. We need to know who to tell and who the collider was. So we would have in our entity so this is who you ran into. So you ran into this. So then in our entity shape, entity it's the other way around. It's the other way around. We have a collision event. Oh. We could just call a method on the entity. Because it's an individual collision. Yes. Not that. Not that. The thing. So then we have entity.collide with we need to be able to ask the other area which collision shape it is. And in the collision manager, we will know that. No, we need a second key. So collision areas have their type index, which I need for when I'm adding an entity to them. But when I get a collision happening, I'm creating a collision area. If I look at collision area, we have events for this, which can tell me I could get the shape, the entity shape, using that information. But I don't necessarily want each of these to fire individually. I think we could, though. We technically want it to be an overlap. No, we could just do area shape entered, because if it's still overlapping, I don't... No, we're going to have to handle that case. can ask has, and we can do a get. This just gets us the areas, which isn't going to be useful to us. We are going to use area shape entered. We're going to do that. And consistent within my own code naming conventions. So this is us. This is the thing that collided. That's the thing we're colliding with. We could use the RID. We could have a subclass that extends a area 2D that would wrap some of these things, but that still doesn't get us where we need to be. No. Still doesn't get us where we need to be. We would need to have in our collection of areas and we have a 2-key dictionary. That's still not good. Okay, we can have 2 independent dictionaries. Because these are relatively immutable. Alright, let's think how this will work. Then each collision area needs to have a collection of entity shapes. Oh. Once I have the colliding area, this is a bit of a mess. This is a bit of a mess. If these were a different type of entity, then they could have a type with them. So I'm still sorting them based on an RID, which is the RID of the actual area here. Okay, collision areas are area 2Ds in every way, but they have an entity category that we can use. So when we are getting an area 2D from this, I'm hoping that we can still cast it. Are we going to be able to cast it? This will get us the local one. This will get us the other one. Oh. Okay. These don't need to be public, but it's under our control, so we'll roll with it. Okay, if we get an event on one of these, seeing if I could daisy chain an event up, but in theory, this should work. It will depend if this actually preserves its type. Since it is an extension of that, this should continue to be one of these. Let's all cross our fingers that Godot isn't doing some type shenanigans in the background. Since a collision area has a type, we can have a public dictionary int hash set of entity shapes. Nope. Is a dictionary of int to entity shape. Okay. So what we're going to do here, again, this little fiasco is going to be an issue. This is collision area. Oh no. Why do I not have a resource identifier for a collision area? Wait. Dot. Hit RID. Okay. I was calling the class as opposed to the instance. Okay. I have concerns. This is complicated. Create the collision area, do the basic configuration, add it to the collections, add it to the tree. We create the indices for it. We create that queue, we add them. Then we are going to int to entity shape. Shapes. Okay. Yep. All right, stepping away for just a moment. Be right back, folks. Turn. Then. Hey, Zelcade. Welcome. Let me do collision area, entity shapes, add. Entity type. Entity shapes. Okay. Okay. So now we have a collection of shapes. So this is the area that we collided with, which both of these should have a type. Effectively, Zell. Effectively. Okay, we have the areas. Each of these has a type. So then we have... dictionary of int to entity shape. Local shapes equal to collision entity shapes this area okay. Another one. No. We can clean this up. Local shape is equal to IntelliSense, work with me here. Shape index. As an int. All right, so we get our local area by taking the RID of the local area. Hey, Wolf, doing well. We're getting started. Well, we are into the weeds on getting collision set up. We get our local area based on the RID of the colliding area. We get... we convert the area that we ran into. This is right. Let me double check. We're going to need to add that to the exit tree. Technically, we shouldn't need to. But I think for proper cleanup, we should. We'll strip the event out just so we stop getting those just in case. All right, so there's our local shape. It's equal to be that. Then say local shape dot collide with colliding shape. Oh, then all right, so we need to get an area. Equal to category may change that to an int inside of the entity just for... Actually, task, can you... So a given area only collides if its mask matches another shape. So for the case of like the player shape, the player area will never get area shape entered because it doesn't look for anything. But if a bullet overlaps an enemy area, the bullet area will get an area shape entered for the enemy area. So it should be that this will be the bullet area and this will be the enemy area. So the bullet runs into the enemy. If I also have the mask be the other way around, that the enemy is also watching for bullets, then I would get both collisions. But I'm trying to avoid double collision. Because that creates kind of a... There's a risk surface to that we may still need. Okay, we need to determine if we need to add a shape or not. is shape indexes. Oh, oh, can I say that this is an int? Like, it's an enumerated type and I'm passing it int values, but can I declare that they are integers so that I don't have to keep type converting it? Because I am casting them currently. Okay. I just wanted to see if there was a shortcut to not having to do this. EQ. Okay, here is our next index. Greater than or equal to server area get shape count of collision area, not get RID. Okay, let me explain this mess here. All right, so I'm getting the next index that is available for that area. Last time was day 82. Wasn't it? Yeah, last time was day 82. Yes. Hmm. We'll address that later. Okay, so we have a collision area that we have retrieved based on which type of entity it is. Then we get the next available index. If that index is an index that doesn't yet exist in the collision area, then we are going to create a shape. Otherwise, we're going to get a shape. For now, all shapes are circles. Else, RID is equal to area get shape, which is area dot get RID. Comma next index. Okay. So now we have the shape. Now we're going to make an entity shape from the entity and the shape RID. This will set the data. Okay, we've got a bit of a convolution here. If the shape already exists, then we're going to need to enable it. If it doesn't, we're going to need to add it. But we always need to do this to set its data. So we could have an add it after. Okay, we're just going to have... area RID, shape RID, comma... Nope, okay. We add the shape. This is, we already have the shape. This will create the entity shape. Then we are going to have entity shape. Shape index is equal to next index. Area RID. We are re-enabling the shape. We are forcing it to be enabled one way or the other. Oof. Then... shape. Not... Why are you not? Fine. Add that in, but it's on entity shape removed. And this one is all that on remove entity shape. And over in entity shape, we have this is the shapes index and where it's going, but isn't quite right. Because I don't know which area that shape belongs to. Now, I could have the entity category preserved within the entity shape. Which I do. So I can have int. And the entity category will then get relayed along, and it will tell me which area to mess with. We'll have to fix something in a moment. This can also be updated. Okay. Entity shape public event. Okay, when the entity shape is supposed to be removed, we get rid of the entity ones, but we're not sending the shape to it. We don't really care about the shape in this scenario. Again, we care about an entity category and an index. Hey there, Savage. Welcome. Hey there, Darwin. Welcome. We're doing well. We're doing well. It is akin to that. We're working on a game here. Let me check something real quick here. Working on a game. Doody-doo. We're checking some Stack Overflow here. Okay. I think I see what we need to do. Doesn't like that. Because this isn't like, this is the parent object. Can we... Because this would be an operator on entity. Seemed like you were on the right track, Tess. No worries. This has... Oh, hey, Nightbot called out. Area is equal to collision areas by category, entity category. You don't really care about D is equal to 2D. Then physics server 2D. Area set shape transform. A collision area RID. Index. It's 2D. A new transform 2D. We'll use rotation and origin, which will be 0. Say float. Position. Since all the shapes are circles, we just need to put it where it's supposed to be. Oof, third language. I mean, that's 2 more languages than I can speak. Okay, we update it, and then when we remove it, we're going to get the same thing here. This is the area that we're going to remove that index from. Area set shape disabled. This is the collision area resource identifier, the index, true. We will actually need the collision area. No, we won't need the collision area. So it's disabled. Then we're going to get the collision area entity shapes. Remove entity shapes. This is int entity category. Remove index. Okay, we remove that one from the collections. And then we are going to say shape indexes. Which is another int entity category. But we're passing it as an int, so we don't need to do that. And Q index. That makes sense, Tass. That makes sense. We will visit that in a moment. All right. Then in entity, when we collide, this is us colliding with target. Since enemies can collide with player, we're going to do this strangely. Move enemy entity this. Okay. A whole lot of stuff just went down. Move entity shape event invoke. Okay. That is... Alright, we need to get this working properly. This is the entity category and our index, so... I'm running it through Godot because we've reached a point where the Godot engine natively is running more efficiently than invoking the Godot engine through C#. So I'll use the C# side for step-by-step debugging, but to see it performing at full strength, we need to go through Godot. Okay, we're not actually getting the collisions right now. Line 87. Collision areas by RID is not instantiated. There we go. Okay, we are still not getting the collisions. So let's do a quick check here. It's another one. Collision area entity shapes is not being configured. Like I said, so much stuff has gone down. Yikes. Okay, we're definitely not getting all of the collisions. At least I think we're not. We're definitely getting a lot happening. So, first off, click. Yeah, there's our problem. Pause. Look at all them errors. So, you notice how they're continuing to animate. That's because this is a shader, not an actual part of the process. So just rendering it on screen, sitting still, is causing it to animate. For 99. That's a new thing. Now we're not adding the collision areas properly here. Because they're not going into the areas by RID, that kind of thing. No, wait, they are. We're adding them into the collection. So why does it not like that? Let's find out if that's actually the case. Okay. not found. Well, that was weird. Okay, we are not... The local shape is not getting in here. That's why. Nope, nope. That's collection. When we're adding the shape. We need to add it to the corresponding thing. This. Click. So player shape, enemy shapes, and our category is 1. So we just have the 1, so we're going to get a local shape. Which is the player shape. Which is backwards. Anyway. In a minute. Area's entity category is 1. The colliding area's entity category is 1. But .909. These are supposed to be different shapes. Oh. Okay, here's part of the problem. This is supposed to be within the collision area function. Like, it's... This one should have a handler. So that this one can emit up and say, I have an event. Okay. So this one will have a collision area collided event. That's the event we will subscribe to. This will have a function in it whose purpose is to relay up its entity category. And that will remove our need for this guy. Okay. We'll be back to this in just a moment. Stepping away. I'll be right back. And we're back. Okay. Okay, so we have collision area collided now. And what this will do is we'll have an on area shape entered here. Have all those methods too. So this is the one that collided with it. So this is the remote one. So this one is going to have the entity category associated with itself, and then it's going to pass back a collision area. Lighting entity category. Index. We're getting there. It's not a collision error, we throw an error, or a collision area, we throw an error, that's okay. That is the only kind of thing that it should be bumping into. We may have to wrangle that later if we add things like walls, but we'll get there. I would be more inclined to add another area and add shapes to it according to like a grid map kind of thing. to fine. So then we have collision area collided. If it exists, evoke it with entity category, local shape index, colliding category, area shape index. Int okay, so if a collision area is collided with, then what we're going to do is we are going to invoke collision area collided here. Entered plus equals collision area collided. Fine. Fine. It is effectively identical. But whatever. Have it your way. All right. So it will raise an alternate event when this Area 2D event is invoked. Hey there, Maraschino. We're doing well. We're doing well. Okay. So now we're going to have a different event. So instead of its area shape entered, we are going to have equals that. And that will totally be a thing that we're going to rename in just a moment. making headway. We're adding stuff. Local shapes are based on the local entity category. Should be a local shape index. Lighting shape. It's important. It's shape index. That is relevant. Entity category, but it's a shape index on the colliding area. Could I combine this into one horrifying glob of function call? Yes, I could. Am I gonna? No. Will I change my mind later? Who knows? It's not collision area that. It is collision area collided plus equals on collision area collided. And then when we are exiting tree, remove connection. And this will all totally work, and everything is good now. Oh, it works worse. Click. Pause. Okay, this is tricky. We want it to stop colliding, but the problem is, as part of this event, it is resulting in it being removed. That can't be right. This should be during the result. This is handled. We're already doing this, but okay, it's coming back around. We are in the midst of another potential physics step, but this should still be okay. Because we shouldn't get here. Just when is it happening? Here. We're getting a bunch of key not found exceptions. Which could be contaminating other results here. That's why. Because I don't have a proper to remove entities thing. So I have entities to add. We'll move this around here. And now I also need entities to remove. NQ. No, there's a... Okay. Entities removed shouldn't be a queue. It can just be a hash. It can be a hash set. They should both be a hash set. There's a reason for this. Just a moment. Come on now. Hash set. This is a just-in-case scenario. This should never really become an issue. It's a for each. Hop back over to add entity. So we check if it's not already there. Same with remove. We're already removing it. We don't need to remove it again. That one. See how the number's flickering? It's because they're colliding constantly. Okay. So now, when we're adding them, instead of it being at this fixed position 0, you're going to add them all at arbitrary positions. Oh wow, it don't like that. Okay, we're getting a lot of collisions. We're getting a lot of movement, but where is all of our cost happening, and are we getting errors? That is the question. Click. No errors there. All right, Profiler, help me out here. All in the physics. Where could we be eating all of our time now? But real quickly, let's get an interim commit here. Too much has been happening. Figure out which cat that was. I need to figure out a good way to profile this. Let's look over on the Godot side for just a moment, and we're going to do add an area 2D, and we're going to look at its properties here. We should have no forces being applied to it. And it's only colliding because there's the shapes applied to it. Let's run again here, and we're going to look at some of the memory content. Click. Orphaned. Not generating any additional physics objects. So there's something about the way that we're doing the collisions that is chewing up processing, but it's not something that I can easily see on the Godot side. It's definitely something that's happening over on the physics side. Over in this territory. I do want to clear out some of this logic. Okay, we are only editing using this one during config. Cleaning up some of this. Don't need to make that distinction anymore. Well, let's run this again. Things can see it, yeah. That should matter. All right, let's do a quick check here. In this, we are going to change the collision layer. That we deal with. Manager, add collision area. Okay. No collisions should happen. All right, creating all the shapes is expensive, and creating, and I suspect, yeah. So there's shape movement, and then there is just creating them. We could pre-populate the shapes. Because we're not getting any error messages. We're just consuming a lot of resources. Okay. We're going to restore that just to make sure we're only changing one variable at a time. Well, this isn't good. We're doing it twice. That's going to cause problems. Okay, collisions can happen, but it's just eating so much resource right now. Okay, we are going to in our collision area manager, we are not going to subscribe to that event. Collisions will never happen. Okay, we're potentially facing that shapes are the problem. Because this is, no collision is happening. But we are updating the shapes. So now we go into an entity shape. And we are just going to... That shouldn't matter. It should be on collision manager's side, which will be on will do nothing when the shape updates. Nothing. Okay, moving the shape is expensive. Can we make moving the shape cheaper? If I had to guess, this is costing us here. Like, I'm wondering if this is not triggering additional collision checks. Because we're changing the shape each time. Get overlapping areas. Get me an array of overlapping areas. But I don't care about the overlapping areas. What I want to get... Let's fiddle with stuff here real quick. Let's try catches out of there. And they're all instantaneously colliding if we don't update the shape, because by default, they're at 0 when they're created. Like, they never get their shape updated. I think. So that's something that we're going to have to deal with in the actual logic, because they should never exist at a position that isn't a position they exist at. All right. Server 2D dot area set shape disabled. Collision area RID index. Ooh. False. All right, the shape is disabled before we move it. Still coding, Ezra. Still coding. If anything, that's worse. Most likely because by changing their disabled state, we're potentially messing with the state of the area again. What if instead of updating them when we move, we make one big update? Where we iterate over all of them and set the data. We would need to have mesh. It is an entity shape. We would need to actually preserve the position. It's a vector 2. E vector 2. Shapes that are the same shape but as a different size. Shapes in this case are individual circles. They can be different sizes. Right now they're all radius 8, but they could be different sizes. Well, thank you, Ezra. Temporary. So we could make individual checks, but there's just going to be so much going on. So we need to avoid that. We are going to have... All right. For each collision area in collision areas, shouldn't I be able to get one? I have been a full-time coder, Ezra. Why that no work? Collision areas is a dictionary of collision areas. Okay. No. Why? Fine. Fine. How do I code continuously for so long? You just do. I am enthusiastic about the project, and coding is something that is. I mean, it's just something I can do, and it's not something I dislike doing. Okay, so we have all the collision areas now. No. We need... for each entity category in the collision areas. So we're going to need an RID. It's equal to collision areas. Antidote. Yep. Love it. So helpful. Hate it when it's not helpful, but love it when it's helpful. Okay, so we have the collision area RID. Now, for each of int to entity shape area shapes in collision area entity shapes. No. It is area shapes is equal to that. So for each entity shape, in area shapes, I'll use physics server area set shape transform collision area RID entity shape dot shape index transform 2D float 0 shape position Okay, we're just setting that, and then in the game, whenever we do physics process, we update the camera handler, and we also call the physics process an entity manager. So we are going to call... public collision manager. So over on the Godot side, we recompile. Now a hash got in there. Over file. Okay. Then in assign camera, and we assign collision manager. Same issue. Well, it's a little cleaner once we're not moving around. So I think maybe the shape creation is part of our problem. So we'll keep this around. We won't call it. And then in our entity shape, we are going to do that. So we're still going to update that. We'll call this, but what we're not going to do... we are not going to actually create shapes. So we're going to do on entity added. No shapes will be created. We're just narrowing down what may or may not be our problem here. Okay. What if in our setup here, we add all of these, and for each one of these areas, we are going to create is it? we are going to pre-populate it with this many shapes. Hello, normal. Welcome to the broadcast. I is equal to 0. Will this be excessive? You bet it will. Create. And that is collision area dot get RID. Add that shape. Start out, it's not monitoring and it is not monitorable. All right, so we are pre-populating disabled shapes into it. We are never creating new shapes. But that don't matter. It is entirely... I'd still like to know where the calls are. And I fully feel like it is that collision is happening as we're doing this. We're also not freeing all of these RIDs, so that's also bad. Okay, didn't make a difference. That's fine. For giggles, we are going to try... it's never monitorable. They can't collide. So nothing collides. Just messing with those shapes, though, is costing us. We're making a game normal. It is a Vampire Survivors game with modular weaponry. Right now, we're implementing collision handling, and we're seeing a massive performance hit to it. Okay. If we limit our creation rate here, and we'll put it at 5,000 for the time being. Okay, 15,000 is too much when we include collision. Okay. That's fine. That's fine. If we can get 10,000, we are still sitting pretty here. The initial warm-up period doesn't count, and we can clean that up substantially. We could have a pile of shapes that exist for us to use. We could pre-build that. $10,000 shapes colliding. It's super expensive at startup, where we're creating like 500 things simultaneously every 4 times a second. So that's still super expensive, but 10,000 objects at about 60 frames a second, with collision happening on each one, including the removal of those entities at the time. Now, again, we need to set up properly freeing each of the shapes, because of that little hitch there at the end. We need to make sure that this is freeing all of these shapes. So, while area server get area shape, which is collision area, get RID. Oh, we don't even need to do. We're going to need to free them, so we need to get the shape, so... Get the first shape, get rid of the first shape. I should do last shape. Should be constantly doing last shape. So... Reason we're doing the last one is it re-indexes all of them every time it does this, so... So, in theory, this should not explode when I do it. So this is the initial load up. So we'll need to get it to where those shapes, I think we're going to try to pre-populate those shapes. Exactly how we do, that's going to be a whole thing. But ultimately, we're going to need a load up period anyway. We've only been going for about 5 hours? Yeah. Yeah. Nice. Nice. Do a quick commit. Okay, in this fashion, I think pre-populating the shapes is a good idea. Because then we will never run into a circumstance where we don't have one and we need to create it during gameplay. area.getID. Okay, this should result in a very substantial lurch at the beginning. Not that substantial a lurch. It's not. Entities times 2. I mean, this is 60,000 iterations, but it shouldn't be that much of a burden. Oh. That shape disabled. Sure, they're disabled. Pre-populating it doesn't seem to really do anything. I suspect because once we get rolling with it, we're messing with their state again. And I think that's the pricier part. So if we were to go into our catalog and reduce this down to 125 at a time. Yeah, creating 525 shapes per second starts to be an issue. So then do we have a hitch point at, say, 25 at a time? We're looking at a point where we're looking for a point where the frames drop below, like, let's say they hit 55 or less. Right there. At about 9,000, we got a hitch. Okay, let's go back into our catalog. Let's make them go fast again. At about 9,000 was a hitch. Okay, what could be happening at 9,000 shapes? No, they start changing behaviors at 3 seconds. That does cause a increased performance cost because that's when mouse tracking kicks in. But not that big. Interesting. Click. But why 9,000? Good call. Good call. Okay, this didn't make a difference. Go into our entity manager. Say 8. Yes, it does. There is something, quote, magical about hitting 9,000. I have to presume that there is something that changes within an area once you hit that many shapes. Or I'm sorry, once you've done something with that many shapes. But I don't know why it happens at that point, you know? I mean, we're still sitting at a pretty reasonable number. Yeah, like maybe there's an internal array that's pre-allocated to a great big number that they think they'll never hit. And that it has to, like, you know, double the array size or something bonkers inside of it at that point to avoid an overflow. You know, old school array handling. Interesting. So what is it? What is it about you that is making that happen? Because it's not until, in this case, 20,000 things have come into existence that we would start to loop back on the collection. So we shouldn't be hitting a loop back yet. And that shouldn't matter because this number is always bigger than the number of entities that can exist at any given time. So we can never exceed that. Something real quick. Physics server 2D dot. Just lost in thought a moment here. Oh, this is a calamity case kind of issue that we're running into. Past 10,000 objects, we start to get into an issue with the physics server handling that number of things, period. At about 9,000, there is a hitch in creating them. Call. Let's see if we spot. Click. And this. Okay, we're going to need to allow it to go to 10,000. Well, let's let it go all the way so that we can get longer to see what's causing the slowdown. Okay, it is... Physics 2D is still eating a lot of time during that. And it's still costing us a great deal of time in that processing. But what else could it be? Self-only. We have a lot of these integrate forces calls. One... Is our primitives flattening out? Shouldn't be our video RAM in there. But I suspect that it's so it's not rendering. Rendering is way down here. Pretty much flat. Our physics 2D is the thing that's eating the time. Each one of these, and there's 1, 2, 3, 4, 5, 6, 7, 8. All of these integrate forces are each 33 milliseconds. Okay. This will be slower when it's running. Well, in theory, it'll be slower. Okay. Now, where can we find... I mean, I've been looking at this, but it... Okay, actions are chewing up, but the most is changing the area transforms. So there is a point at which making this many changes to it is causing it to slow way down. So visually moving stuff around is expensive as well, but a chunk of our time is being spent in the physics server. Okay. The hot path in code is calling the interop method. Good idea. Let's take a look. Gonna remember where that was. There we go. Right, there's it, 8K. Okay, at only 8,000, rendering is more expensive than physics. So this is climbing faster as far as the expense. Not shocking because this is kind of linear. More entities means more, like, I have to stamp more things onto the screen. But there isn't, like, collision handling or something. Our sorting is the most expensive part of that, as far as computation. But with this one, every time I set the transform, every time there's another thing setting the transform, I have increased the complexity of that. Now, there might be something we can do to make this cheaper, but I don't know how to make it so that we delay it, you know? I wonder if... No, bullets are still going to cause some of that problem, but I wonder if adding navigation will actually make this cheaper. Because physics server calculations happen once at the end of the physics, or during the physics step. It does not account for any movement that happened during that physics step. So it will be, where are we now? Calculate that, and then do all of the, like, Godot physics engine movement, which we're not using. So is it possible to make it so that this happens at a different pacing? What if... This is with 30 physics frames a second. I don't really want to go under that. You know, we could say there can only be 2 physics frames per visual frame. We'll set that back shortly, but... Okay. Then with that set... I don't need to compile before I run. It's going to build it anyway. There's still that hitch, even with fewer frames per second. That hitch is something different. It is costing us, like, we're doing most of the processing in that period, but... there's something more to it going on, you know? So I would still like to keep at a high number. I think we're still in reasonably good shape. The reason that I think navigation might help us a bit here is that navigation moves the actual movement out of physics processing. Like, that becomes a different step. I wonder if updating all of those off of the physics step could help. Because again, it's the collision stuff is handled once during the physics step, but because I'm moving all those shapes constantly, maybe that's causing some of the trouble. Because I tried updating them all at once, and that still causes the issue. Because we can't just say when it's moving, don't collide. When we alter those transforms, don't collide. But maybe we need to. Because one of the thoughts is this causing an update? Is moving it causing it to recalculate the simulation? We'll have to look at that more later. I think we are. I think we're at a good stopping point. So, effectively, though, we have collision working. We have collision working up to 10,000 objects, which is still really good. We are still about 4 times higher than we could get prior to going into C#. And 10,000 objects, as we can see, is a lot. About 700 16 by 16 entities on screen. Maybe 1,000 enemies on screen is more than enough. Active at once. That will more than fill the screen if they can't overlap each other. Projectile-wise, then, if we had one projectile for every one of those 1,000 entities, then we're still well below our 10,000 marker. We're still well below our 8,000 marker. We would need, again, 7 projectiles per entity that would overflow the screen by a goodly amount before it becomes a problem. And those entities, those projectiles, are eventually going to get culled some distance off the screen and after a period of time. So we're less likely to sit at maximum entities on screen. So I think we're doing okay in that regard. We can add navigation back in next for when the blobs are created. That will also be a good stress test, because if the blobs are moving the way they are right now and they're having to do navigation, that creates a noticeable extra burden on the system, because they are going to be slamming into each other really quick. But yeah. So we made good progress today, though. We made a lot of progress today. And the next thing will be navigation, and then we're going to move back into getting the inventory rolling. Right around that time, we might also do an art revision to start shifting to that 32 by 32 or higher. I don't know if we're just going to do that for UI or not, but we definitely need a higher resolution for UI icons. Otherwise, we just can't do a lot with 16 by 16 icons. But bumping it up to even 32 will give us a lot of space to draw in. We'll see. But I hope everybody had a good time watching today. If you like what you saw and would like to see more, remember to like, follow, subscribe, all that good stuff. It'll help you find the streams more easily in the future. If you'd like to help financially support the channel, you can do so through Patreon, Ko-fi, and YouTube memberships. With all that said, I hope the rest of your day is good, and I will see you next time.